this is Hrudai from the US.
This is Vatsa reporting from India, and this is
VHDTV. How is it there?
Sorry?
How is it there? What, any plans?
No, nothing specific. It's just a normal work day. It's raining.
Yeah.
How about you?
Yeah, here too, normal, just normal. Nothing, nothing planned. So, do you want a sneak peek to the topic?
You should start with this topic, I guess.
The topic is the birds that don't get concussions.
Birds that don't get concussions.
Yes, concussions. So, do you know what a concussion is?
Yes, I do.
So,
but you should explain.
Okay. A concussion is when let's start here. Your skull is pretty sturdy. It's really sturdy. Take and knock your head and you'll actually hear a noise. It's pretty sturdy. But that jello that's inside of your skull, you know, the thing that we call the brain, that is not. It's exactly how I said it. It's jello, basically. So when jello rams into a really hard thing, it kind of squishes, right? And sometimes it kind of starts breaking apart. That's the same thing that happens to your brain on impact, like serious impact. So that's not good for us. That's what we call a concussion. It slams into a side of your skull, and then kind of the neurons start ripping apart and you might feel dizzy. Thank God I have not haven't had a concussion before. So that's good.
That's good.
Yes. But now what about the bird part? So the bird that does not have concussion is a bird that willingly slams its head into wood. Of course, I'm talking about the woodpecker.
Woodpecker.
You know those.
Yes. Yeah.
So guess what? These woodpeckers peck about 20 times, not a minute, per second.
Are you kidding me?
Yeah, they peck like super fast. I can only peck with my finger about 3 times a second. So it's wild, really.
Yeah. It's high frequency.
Yeah. So when a woodpecker strikes a tree, don't you expect its whole brain to get an impact? Because we just talked about how concussions are the brain ramming against the skull. Don't you expect?
I do, but is it strong enough? Because, for example, what if I do this? A brain is not slamming to the skull, right? It is still low impact. But
yes, but imagine doing that 20 times per second. That has to be an astonishing speed. So if you do this fast enough, as fast as the woodpecker, even not ramming into the wall, you might actually get a concussion, even though you
let me not try that.
Yeah, don't try it. That would be superhuman. So, and it keeps it up 10,000 pecks a day. So keeps up doing that. So the vibration will get absorbed, not to the brain only. So when we hit, it just goes into the brain and it goes to the skull. So that's really rapid. But it's almost like sleeping on a bed of nails or standing on a nail. So if you sleep on a bed of nails, that the force will go evenly and you kind of won't get hurt.
Right.
But if you step on a nail, you all know what happens. You get cut.
Right.
So this is the same thing. The woodpecker has its brain, its skull directs the force completely out of its head so that the head does not get harmed. But instead, it goes to the entire body instead.
Okay.
So say this is like a backup plan. The backup. Say that the woodpecker's absorption to the entire body does not work.
Mm-hmm.
What does the woodpecker do? It has another thing, not quite as strong, but it's good enough. Its tongue. It has its tongue.
Which takes a vibration?
Not really. The woodpecker has something called a hyoid. So this the tongue, except it's bonier, so it goes at the end. We also have a thyoid, but it's below the tongue. But this the bird's thyoid is a hyoid. So the bird's hyoid, I think, is connected to the tongue, or the tongue is the hyoid.
Mm-hmm.
So it like wraps around the brain and then connects to its eyes. So imagine it starts at its mouth, like here.
Mm-hmm.
Then it goes all the way over to here.
Mm-hmm.
And then it goes into the eyes and connects to the eyes.
Okay.
So that acts like a cushioning around
Shock absorbers.
the skull. Yeah. So that helps the skull stay in place, I guess, and the brain won't move. The brain won't lurch.
Mm-hmm.
Also, a plus side is that our brains are in the middle of water-like substance, and then it is the skull. But the brain of the woodpecker, which is small, I'm not saying it's not smart, but it's pretty small, compact, it doesn't have a lot of space to move. So it usually doesn't move.
Got it.
The brain is oriented in a way that it has the least impact. So here it is. So
are you reading something?
No, I'm just citing something from the text.
Okay.
So when the brain is really small, it has a high surface area to weight ratio. This is another way that it helps spread the impact force over a much larger area, causing less damage. So basically what that means is, what I think of that is, it's slanted, or it's in a different position than our brain. It's kind of oriented in a way that makes more part of the brain, if it gets the impact, more part of the brain to get the impact. So instead of our brains, how we get it, when it's like just one point, it just hits at one point, all of the force.
Right.
Instead of that, it's distributed. So there are positives and negatives with that, but
what's the negative? What's the negative?
The negative is kind of the entire area will kind of get shocked and not relieved. I think that's basically what happens, but it's not a big deal for the woodpecker. Right. I don't think.
Okay.
Then the brain is protected by a tissue thick. It says thick plate like spongy bone. So that's what the brain is surrounded by. So the woodpecker's brain.
So another layer of shock absorber. Another layer of shock absorber.
Yeah. So you felt a sponge before. When you squeeze on it, it flattens, and then it bounces back. So it's basically like a trampoline, a shock, a spring. So even if this is the utmost protection, even if the brain slams into the bone, it'll still be safe because of that spongy bone of protection.
Awesome. So to summarize, it has 3 techniques, I guess. One, it is absorbed through the entire body. Second, the tongue wraps around it. Number 3, it's the spongy, bony structure that acts as a shock absorber. And fourth, it's very compact in size, so there's not much movement, and it's the orientation actually helps to increase the surface area.
Yes, yes.
So there are 4 things. Awesome.
Yes.
Thank you so much.
So, one last note. Scientists have seen that NFL football players, they literally ram into other players.
Right.
So that makes the concussion rate like seriously high. And that's really dangerous, even lethal sometimes.
Right.
Maybe. So even when that happens, they're trying to use the birds, the woodpeckers, anatomy. They're trying to use the woodpecker's anatomy to help make the kind of helmets or make the players more resistant to concussions.
Got it. Yeah, that makes sense, because there were many cases after the retirement. NFL players got into some issues because of these. The impact that they had in the past. So that would be a really good solution if they can come up with something that is viable. Yeah.
So I had seen a horrifying picture where it showed a normal brain, which was good, pink, and healthy. It was about this big, while these NFL players' brains were, like really damaged brains were like this.
Oh. Okay.
It was really spongy and it was horrifying.
Yeah. Be careful. Don't watch such pictures. Sit with Amma if you are watching those things, okay? Because you'll find all sort of nasty stuff on the internet.
Yeah.
Be careful.
Yeah.
Okay. This was good. Thank you so much.
Bye.
Bye. Take care.
Go VHDTV.
Go VHDTV. Bye.